schematic can perform S parameter simulation using Keysight ADS. The simple example we'll be doing will illustrate how to use ADS to perform a single a S parameter simulation on a simple circuit. To get started, we first of all need to create a workspace, which we can do by just clicking the W sign there on the menu. So you can name the workspace anything you like, and we'll just leave it in the default workspace. So after creating the workspace, by the way, the workspace is where all your files relating to a particular design are stored for easy access. So after creating the workspace, the next thing we need to do is to create a simple schematic which will be used to design our circuit. So we just name the schematic, leave the default naming as we say one. So this is our schematic, and after our schematic is created, what we need to do is to place our components on the schematic. So from the schematic, we're going to build a simple circuit. So we'll now go from on the left side. You see all the model that ADS have. So what we're going to use now, we're going to go to long components. You see a long component, and we select the elements we need. So for this, we're going to use a simple L pad, a C pad, and we'll just use the arrow. No, we're not using resistor for this. We need inductors. So we'll use 3 inductors for this circuit design and 2 capacitors. This simple design is more or less like a filter. So we need to add we need to add a terminator too. From the component menu too, we can select from the simulation palette simulation S parameters. Should be somewhere here. S parameter. We'll add the temp gem for both sides. It's like a terminator, and this is usually the default is 50 ohms. You make sure they are numbered according to this is num1 and that's num2. So we're using the default which is 50 ohm. Actually you can use any value you want, but the basic standard impedance of any device these days is usually 50 ohms, although they have some that use different impedances. But for this, we all use the standard 50 ohms. So we invert, invert this so it can fit in our circuit, and this as well. So make our connections as appropriate. this this was then grounded. It's just standard device setup. You ensure that the terminators are properly connected, and and here our capacitors here are properly grounded as well. They will now will change our values here. Just we can use any value, but actually, if you are making a design, you should have calculated values for your design, which you can input in, because there are different circuits, and different circuits have different values for different purposes. So for this simple one, we use 100 L1, we use 80, 8 nano Henry, and we use here another 100 nano Henry. And for the capacitor, we use 5 picofarad for both of them. So from the palette here, we need to look for the S param, which is also where the S param in the simulation palette. So we now look for our SP, which is our SP controller, and add to our circuit. And then you double click on the S parameter and change the values. So for this particular one, under the frequency tab here, we change our start frequency to be 0.01 and our stop frequency as 0.5. These are gigahertz. I'll use a step size of 0.5 or 5 gigahertz or 5 megahertz. That's about 0.05 gigahertz, and we use that will give us a step size of 111. But let's just change this to 4.9, and so we can get a step size of 101. So we have a middle value in between. So we now go to the parameters tab and select what we want to display. So here we ensure that S parameter is selected because that's what we want to show, and then we click on OK. So our design is now set for simulation. On the menu, we now click on the drone simulation, which is this J sign. Clicking this will now run our simulation. That's the simulation icon from the toolbar. The simulation. Okay, so there's already a simulation running. When did we do that? Oh, okay. I don't know. Simulation is running. We don't know. Yeah, okay, maybe on that simulation. Okay, click it twice. So after running the simulation, we now so after running the simulation, we now move on to plot our simulation results. So when the simulation is complete, right? We can view the simulation result in the data display window. So this is the data display window. To create a new data display, we need to this is what is you can say this is our data display window. So the data display window here now, or when you first run it, a blank display is shown. So we need to do now is select our rectangular plot here. Click on it. You place it anywhere on the display window. Then for this particular design, we want to plot two parameters. the S11 and S21. So when you click on the S11, you first click add, and we want our result in DB. So make sure the DB is selected and click OK. If we click OK here, you see our our graph, our plot for the S11. We can also add S21 by double clicking on the plot. So this one will bring us our plot traces and attributes uh, uh, type. So we're going for S21. We'll click on S21 and we'll add it as well while selecting DB. So, and when we click this, we now have our two plots shown on the screen. So the blue one is our S21. That demonstrates the relationship between the input and output. That's a voltage wise is a V output voltage is relationship between the output voltage over input voltage, while the S11 signify how well matched the circuit is. It's called the return loss, and it demonstrates how well the circuit is matched to the impedance. So so our results are displayed here. This is how we run a simple demonstration. We can proceed further to do a parameter switch and see how our simulation will perform when we use different values. For example, to do this, we can define a variable definition here and say L1. We define this as L1. No, L1. I'll put the value here, say 100 nanohenry. I'll click apply. L2 as you don't need to put here as L1 is 100, not nanohenry, because the 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 nanohenries will be defined there. So we apply this and change it. So L2 as 8. We add this. So if you click apply again, it's going to override that. So we need to continuously add when we are putting in new value. We put L3, this is 100, then add C1, which is 5, we add, and C2, change one thing and add. Our C1 is 5, sorry, not 100 there. So we apply this and say OK. So we have our value now. What we just need to change this to L1, L2, L3, C1, C2. Basically, what we've done now is just represent our value here with variables which we have defined here. Basically, as at the moment, we've not changed anything. So if we want to do a parameter sweep, there is a palette on the palette here, a simulation palette. There is a model called uh, parameters PRM SWP. Is a short form for parameter sweep. So here you can say, okay, let's do a sweep of our SP1. Now we're doing a switch of we do a sweep of L, say for example L1, we put L1 there, and our simulation instance name, which is our SP1, and make sure they are in a double quote, otherwise it will give you error. So if we're sweeping from, we're using sweeping L1 here, so we can say L1 originally is 100, and so we can say let's sweep from start value of maybe 80 and stop at 120, using a step of 1. So if we run this, it's going to give us, you see, we'll give this is the value it give us. This is because we're using a step of 1, so this total like 100 different values. So what we do now, we go back to our schematic and change our sweep, say to 10. So by changing our schematic to 10, because what we did before, we sweep from 80 to 120, which is a total with step of 1, which is a total of 40. So what we'll do now, we'll reduce that as the sweep from using step of 10. So from 80 now to 100, we'll swap it from 80 to 120, which is 40, a step of 10. So we expect that it will give us just 4 plots. So if we run the simulation, you see what we have now. We now have 1, 2, 3, 4. So we have at various value here, at various value. If you say this at 100 and at L1 equals 80, we have 235 and frequency is 230 at this value. So we have each of the line gives us the value at that particular inductance. So with the sweep, we can be able to determine which is the optimal from this graph. Out of the 4 plots, our optimal value. So we can select that particular one. For example, if we say we prefer this particular plot, if we prefer this particular plot, say let's put a marker there. If we prefer this particular plot, we have this is the value at L1. All we simply need to do is go back to our L1 and change it to 110. So that will not give us just a simple plot because we are not running that now. So it give us a simple plot without value of, you see, of our is giving us an at 120. L1 is 120 because it's still giving us. So that's what our sweep will give us. Yeah, the L1 before was the value we got from. So if we put this new one here, it's L1 120, even though we're using L1 as 110. Yeah, because it's still sweeping, it's giving us that value because if we disable this, because it's still sweeping, that's not what we have. So if we run this, you see the L1 now is no longer there. So it's giving us the frequency and the dBs. So that's how we use S parameter in ADS, and at the same time do a parameter sweep. Thank you for watching. I hope you enjoyed the video. If you like it, you can click on like, and if there's any other information you need, feel free to contact us. You can use the message box to contact us, or the comment section. Then we'll get back to you as we can. You can subscribe too, and thank you very much once again for watching.